Miss Soma's here. Okay, so today I'm going to be talking about scientific notations. And I hope that you watch my video on powers of 10 first before watching scientific notation, because that would help you understand how to express numbers in scientific notations. So there are really a bunch of ways we can write our numbers. And one of them is to express it in scientific notation. But why? So scientific notation is used to express numbers that are very small or very large amount. So for example, I'm gonna have 426 million right here. And imagine if you would have to write 426 billion. That would be too much to keep on writing a bunch of zeros. So that's why we have scientific notation. So let's go back first to the powers of 10, because that would be very useful in understanding this concept. So I'm just gonna list down our powers of 10 here. I'm gonna start with my 10 to the power of 5, which is 100,000. 10 to the power of 4 is 10,000. 10 to the power of 3 is 1,000. The power of 2 is 100, is 10. And then if we will have 10 to the negative 5, that is 100,000. So tens, hundreds, thousands, 10,000s, 100,000s. And then 10 to the negative 4 is 1/10,000th. So that means tens, hundreds, thousands, 1/10,000th. 10 to the negative 3 is 1,000th. So that would be tens, hundreds, 1,000th. 10 to the negative 2 is 100th. So tens, 100th. 10 to the negative 1 is 1/10th. 1/10th. And there's our 10 to the power 0. Okay, so in writing scientific notation, you are allowed to only have one digit to the left of your decimal point. So we call that significant number. All right, so let's see. If I would have 200, for example, let's start with something very basic. So this is actually 200s. So now I can write it using this 100 right here, and there are two of them. So now I can write it as 2 times 100. But what is the shorter way of writing 100? So now I can also write it as 2 times 10 to the power 2. Okay? Now let's say, for example, 3,000. So now I can write it as 3 1,000s. So now that would be 3 times 1,000. And I can express my 1,000 as 10 to the power of 3. And there's your scientific notation. Now let's try 220. Okay? So again, I can use my 100s here because I'm on my hundreds place. So now I can use 2. So that's 200s and 2 10s. So now I can make it 0.2 times 10, times 100. All right, so now 2.2 times 100, that brings you back to 220. And then that would be written as 2.2 times 10 to the power 2. And as we keep doing this, eventually you'll develop a shortcut. And then let's see, 3,400. Okay, so now I'm going to use my thousands. So that's 3 1,000ths. Okay, so 3.4 times 1,000. So 3.4 times 10 to the power 3. because 1,000 can be written as 10 to the power 3. All right. I think by this time you're kind of like seeing patterns here. So if I will have an exponent of 2, look how many places did I move my 2. So now I would have 2 and then followed by decimal point. And how many spaces did I move to the right? I moved twice. So now 1, 2. So 2 times 10 to the power of 2 is also equivalent to 200. And if I'm going to do my 3 times 10 to the power of 3, now I'm going to multiply it by 1,000. So now I can do 1, 2, 3. So now it's right here. So 3 times 10 to the power of 3 is also equivalent to 3,000. Now, my 2.2 times 10 to the power of 2, so I'm going to have 2.2. I move it 2 steps to the right. So 1, 2. It's now there. I fill this in with a 0. So now it's equivalent to 220, just like we have in the beginning. Now, a 3.4 times 10 to the power 3. So I move 3 places to the right. 1, 2, 3. Okay, and that gives you 3400. Okay, and we're back to our original number. Okay, now what happens if we are writing a very small number in terms of scientific notation? So let's start with something easy here. 0, 0, 6. Okay? So this is tens, hundreds, thousands. So 6 thousandths. So meaning I would be using my thousandths. This one here. All right. So now I can also write it as 6 times 0.10 hundredths thousandths. Because that's really just 6 thousandths. So 6 thousandths. Which, this one, I can write it as 10 to the power of negative 3. Okay? So 6 times 10 to the negative 3. Or you probably have noticed, oh, I could just simply, remember what I said, you are allowed to have only one digit to the left of your decimal point. So that means that you've got to move your decimal point. So this is my very first digit. Okay, then I have to put my decimal point here. So that means I have to move it 3 steps. 1, 2, 3. Okay, so now it's 6 times 10 to the negative 3. And how will you know if your notation represents a very small or a very big value? It's when the exponent is negative, that means it's a very small number. Or if it starts with a 0, that means it's a very small number. So let's try a few more. Okay, so let's see. 0.00029. Okay, so again, you're allowed to only have one digit. So that means I would have to stop right here. Okay, so I need to have my first digit to the left of my decimal point. So that means I would have to move 1, 2, 3, 4. All right, so now it becomes 2.9 times 10 to the negative 4. Okay, let's do a bunch of practice exercises for you to see. And as I'm doing this, I would like you to practice on your own as well. So let's try. 6,400. Okay? So now, again, you're allowed, this is a very big number because this is more than 1. So if a number is more than 1, you know your exponent is going to be 1. So this is 6,400. So I'm going to be using my 1,000. So that means, and I'm going to look at my first digit. Okay. So that means 6.4. You don't have to write the zeros. Times 10. Okay. So 1, 2, 3 to the power 3. Let's try 8,000. Oh, let's do 80,000. Okay, so I'm going to do my very first digit. Okay, then that means I would have to move 1, 2, 3, 4. So that means 8 times 10 to the power 4. Okay, let's see. 126 million. That means I'm going to have my first digit and then copy all the rest of those non-zero digits. So 1.26. Then let's see how many steps we moved. 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the power 8. And then if we're going to do reverse, how am I going to change my scientific notation into standard notation? Let's see, 2.6 times 10 to the power 4. Okay, so all you need to do is write your number here, your 2.6, and move it 4 steps to the right. Move your decimal point 4 steps to the right. So 1, 2, 3, 4. It is now here. Okay, then fill this in. That's no longer there. 1, 2, 3. Okay, so now write it neatly. So it's 26000. That means 2.6 times 10 to the power 4 is equivalent to 26,000. Okay, how about 1.25 times 10 to the power 5? Okay, so you do the same process. 1.25, and I'm going to move it 5 steps to the right. 1, 2, 3, 4, 5, and put your point here. And it's no longer here. And fill this in. I'm just showing you the shortcut now after showing you the concept. So now it is 125,000. And always write it neatly, because this, if you leave it up to this writing right here, then it's kind of like messy. So sometimes it's hard to really see what is the value of that number. Okay, now let's look at some small numbers here. 0.00082. Okay. We have to find our first digit. That means we have to stop our point right here. Okay, so now how many steps did we move our point? 1, 2, 3, 4. So now it becomes 8.2 times 10. Since this is a very small number, we use a negative exponent. Okay, now let's try another one. 0.000004. So always find your first digit. Here is your first digit. That means you have to stop right here. You have to have 1 digit to the left of your decimal point. That's how you write scientific notation. So we moved it 1, 2, 3, 4, 5, 6. So now you write it as 4 times 10 to the negative 6. That's how simple this is. Let's do one more. 0.000235. So first is find your first digit. There it is. And this is a very small number because it starts with a 0. So I know my exponent here would be negative. So then that would be 2.35 times 10. How many steps did we move? 1, 2, 3, 4, 5 to the negative 5. Okay? So now if I would have to give you a bunch of scientific notation, you can easily tell which one is smaller and which one is bigger. So let's try arranging scientific notations, numbers written in scientific notation. Let's say 2.3 times 10 to the negative 4. I also have 8 times 10 to the negative 4. I have 9 times 10 to the negative 5. I have 2 times 10 to negative 1. I also have 8 times 10 to the power 0. So when we did the work over here, you kind of like notice that the value of the number is being hinted by its exponent, the value of its exponent. So this one is more than this because negative 4 is more than negative 6. So our shortcut is to simply look at the exponent. Okay, so which of the exponent is the smallest amount? So the smallest exponent here would be negative 5. So this is my smallest number. So 9 times 10 to the negative 5 first. Followed by a negative 4. Oh, there are 2 that has an exponent of negative 4. So I'm now going to look at the number. So which one is less, 2.3 or 8? So 2.3. So now it's followed by 2.3 times 10 to the negative 4. Followed by the other negative 4. 8 times 10 to the negative 4. And then followed by a negative 1. So 2 times 10 to the negative 1. And then followed by 8 times 10 to the power of 0. And if you really want to work through this as well, so we can also write this in terms of decimal numbers. So now it's really 9. And then my point is here. Then how many steps do I move back? I have to move 5 steps back. 1, 2, 3, 4, 5. So now that is 0.00009. And then this one is 2.3. I would have to move 4 steps back. 1, 2, 3, 4. So it's 0.1233. All right, so you see here, this is tens, hundreds, thousands, 10,000s. This is 9 100,000s. Okay, and this one is tens, hundreds, thousands, 10,000s, 100,000s. So this is 23 over 100,000 as well. How many zeros do I have now? All right, so look, which one is more? So 23 100,000s is more than 9 100,000s. But then again, you can always just do the shortcut by looking at their exponent. All right? Okay, bye-bye.